So, hello everybody, thanks for having me. Sort of one of the topics of this talk is just the fact that worlds are colliding. This is me, like, way too long ago for me to mention how long ago it was. But actually, music was why I got into computers. I was actually trying to record and sequence on computers, and I realized that I could actually sit at the computer for huge lengths of time and not be bored with it. So that sort of led to learning to program and do other things as well. Yeah, did you all laugh enough at that yet? Yeah.
Top right. Wait, let me get a picture. All right, we're good.
Oh, I forgot to get everybody to air guitar first before we start. Okay, so web audio is actually, it's a huge topic, and we could do like a week-long course just in everything that's available in it. So I'm going to touch on a bunch of subjects in it. I'm going to go pretty fast over the top and deep in a few areas. But the first concept that you need to know is that it's going to run in all the browsers. So it's got very good support across desktop browsers and mobile browsers. So it's fully supported in all core Cordova platforms. And Node Electron as well, so super powerful. So the first thing you do is you create an audio context, and you're going to do everything inside this context. Unfortunately, you still have to prefix on Safari, but you can work around that pretty quickly. So you'll usually see code like that to get around it. Simple example, loading a sound. So we use XHR under the hood. We're essentially going to load a file, and we want our response type to be an array buffer. And we're going to ask the context to do the work for us. So at that point, we have a buffer that we can store in memory, and when we want to play it, we actually just wrap it using audio context, and we can play it directly. So here's an example of that. Just quick and dirty, we create a buffer source node, and we call play on that. And it has a bunch of other things that we can do to the audio. For example, the start there, 0, we can actually delay start, because timing is a pretty big issue in web audio. Generally, the source node is for short audio. So if you want to play an MP3 file, this is not the way that you would do it. That's where the audio tag comes in. And actually, please don't use the Cordova plugin media plugin anymore. We want you to use audio for audio, and you can still do all kinds of really cool stuff with web audio as well, wrapped around that, or you could just call play directly on a file. So in this example, we're using an audio context to get that source element, that data, and we can actually do additional manipulations on it. So I'll show you a quick example here. Okay, so this is a very basic example. I'll show you the code first. Where are we? All this code is available as well on a repo, so you can go back and check it later. Load sound is a very simple HTML page. So we can see that we've got this audio tag in there, and that's what's going to happen when way too many tabs. So that's what's going to happen when I click this button, and I call this for Phil because this is his favorite song. This is also a song that I wrote that we use for testing Cordova Media plugins. So we used to have 100 devices on the device wall, and every time you ran tests, you would hear this song run about 5 or 6 times, and we could tell when other people were running tests. Let me just, you're welcome. So a lot of the PhoneGap team is somewhat irritated by that song, so I do need to write a newer song for that. Interesting though, because we are routing this through the audio context, we can do things like create a delay on it. So in this case, I've created a synth delay. This is all, I mean, above here I do create a context and make sure that we have a valid context before we're doing anything. And I am going a bit fast, but I want to show you all the cool little parts too, so I gotta go high and then dive deep and then back up. So hopefully you'll follow, and you can always go back and look at it later. So what we're doing is we're going to create a delay. In web audio, we get what we call, inside the audio context, there's a whole graph. So you can think of a graph as having a bunch of nodes that perform different operations. So in this case, we have a media element that's like a source file. So we can create a delay and feed the output from the source file into it. There's also things, there's a merger. So we're going to split and merge. So we essentially have 2 sources. One is delayed and one isn't. And I can set the delay time for this delay to be, say, 2 seconds, and go back to, and if I just reload and play the audio, it'll be like twice as annoying because we're going to hear it split. So we're playing it twice at the same time, 2 seconds apart. Fun. And also back to the other type of audio, just creating a short sound. This is more if you want to do sound effects, if you want to do any sort of pitched instrument type of effect. You'll load a much shorter sound. In my setup here, I'm loading a shamisen C4. That's the note of the actual sample. And then on click, I'm going to create the other buffer source. So this is the quick one that I can do additional manipulation on and is made for short samples. So if I just show you this one here, so we load a sound, it's ready almost immediately, and then we can play it sound. So that this one, you can see that I'm playing that buffer multiple times, and they're overlapping. So there's a lot of things that you can do with that. You can manipulate the pitch, and you can run that through different effects nodes in the graph as well. So multiple ways to create audio sources. Typically, you'll use uncompressed data for the short sample stuff, so you don't have to do a lot of processing loading it. And then if you're playing like a longer media file, you're okay using an MP3 or some other compressed container. You can also create oscillators, and this is where you get into all kinds of synthesis stuff, and it is quite fascinating. That's the element source, so that this is a video or audio tag, and you can also use this to process the audio of a video. So you can do all kinds of crazy stuff there as well. Web Rtc Media Stream, this is coming from the camera or the microphone, and it's not really there for mobile, but expect it, in the next year or two. So again, generally you'll stick to uncompressed, short, high fidelity WAV files for samples, and then MP3 or whatever for more streamable formats. Keeping time is an issue because if you want to build a metronome or a drum machine or something like this, what happens is you need a reliable way to know that you're going to be called in time to actually trigger the sound. So what you end up doing is you request animation frame, like we just heard about, and what you're going to have to do is you're going to have to say, well, I'm being called so often. Do I expect to be called again before it's time for me to play that sound? And if I don't expect to be called before that next sound, then I can schedule it to happen regardless of when I'm called. So you sort of have to play with it to get a confidence level of how far out you want to schedule your sounds. But I mean, this is sort of one of the struggles with web audio and JavaScript performance. You can, of course, also schedule sound way out in the future, but if you're in a drum machine or a metronome and the user can change the tempo, then of course all your scheduled sounds are going to be out of time with your new tempo. So a concrete example of this is an application I wrote called Adagio. I'm wearing this shirt. And it's a metronome app you can get in the App Store. It's free. And this actually is not yet using web audio. When I wrote this, I had to go deep into iOS and find a way to trigger sounds instantly, make sure that they were loaded. Very much like, I can't remember the name of the plugin, but it was a fast audio or fast sound library. So I did a similar thing, and this is really just using Raphael.js, and it's meant to be a visual metronome. So even without sound, you can see a conductor's pattern, and you can follow along. But it took me a while to get that the timing for scheduling the next sound so it would be right in sync with the actual moving of the conductor's hand. Okay, back to here. So this is the super safe way of requesting animation frame. 99.99% of the time you're going to get the first one, so you don't have to worry about the rest. Next up, I mean, we've accomplished how to time things and how to keep track of time. The next thing you have to be conscious of is pitch, if you want to tune notes. So one of the most important things is you first have to know the pitch of the note sample that you're using. From that, you can use this awesome formula here to generate what we call true tempered or true equal temperament for 12 notes. So basically, given the fact that we know that 440 is MIDI note 69, we're going to generate a range of pitches from MIDI note 0 to, in this case, I'm looping on num notes, which is 128 different MIDI notes, and generating the frequency for all of them using that. If you want to spend an afternoon reading some interesting stories, read up on A440 versus A432. The short version is that there was no standard about what we called an A on an instrument until a Nazi said it's 440. And the other part of the story is that 432 is the note of the universe, based on the fact that it's 4 times 108 hertz, regardless of the fact that hertz are based on seconds, which is a concept that doesn't make much sense with the rest of it, but you can read all about the conspiracy theories around that. So just to demo another application of mine called Frets. And this is all, I mean, a lot of this is running in the browser. I'll show you some stuff on a simulator as well. But really, it's just to make the audio routing easier so I don't have to use my phone as well. But Frets is a chord dictionary that's open source. You can check it out at my GitHub. But essentially, you're loading a chord. This is Framework 7, even though it doesn't look anything like Framework 7. And it has the ability to strum a chord for you, and you can freely play each note of the chord. So that's using that math, and that's using one audio sample. So one audio sample of A440 played on a guitar, and we're able to transpose it even to a low E, and that's probably about the limit of how far you would want to transpose down. If you're going to do this and you want high fidelity, good sounding, you're probably going to use a range of samples. So really only 3 or 4 notes difference, not the whole guitar fretboard. So I wrote a tuned instrument module that you're free to use if you check out the source code to that. And it essentially does the work of loading a sample and applying all the transformations to all the different pitches so that you can trigger it with just calling it with a MIDI note number. Another example is just building a piano keyboard in HTML, which I found was a very interesting thing to do. So this is the way I approached it. I ended up with a bunch of divs for white keys and then a bunch of divs with black keys over top. And I did that to come up with, we can show this one on here. And that's how I came up with that keyboard, which doesn't quite fit on the screen. So then behind the scenes, I'm using my tuned instrument class to get pitches. Behind the scenes, I am looping through all of those elements, and I'm just adding listeners, and they all have a data which tells me what actual MIDI note they are. So when any one of those is pressed, I can, where is it? On piano key down. So I can get the actual data from it and just call piano note on with that note number. And in this case, I'm transposing because it was way too low. So I'll show you that a little bit more when we get into the synthesizer stuff, because I have it hooked up to an oscillator, which hopefully will sound awesome. Probably a little buzzy, but there's all kinds of things that you can make. You can make oscillators, sine waves, square waves, triangles. You can do your own. You can use a sawtooth. And also the audio graph that I spoke of, you can create like individual components, gain nodes, which change the volume of their input to their output. You can perform reverb effects, delays. You can split channels and then merge them and do different things. And you can even do like an analyzer node, which just simply observes data coming through it. So who knows what an arpeggiator is? Tommy. Oh, a few of you. Okay. This I think is the best example of an arpeggiator. Do they have this show on Netflix in Amsterdam? Yeah? So that is really just a keyboard player holding 5 keys. And the actual synthesizer is going, I'm going to play the notes like that. So really the piano player isn't doing anything in this case. Another example, if you want the boring version, it's almost the same song. Anyone see this movie? Only God Forgives? This is, where's Al? Al's favorite song, or favorite movie. Yeah, it's been 5 seconds and no one said anything. But then there's the arpeggiator. And eventually they fight. It's going to take like 5 minutes before they're close enough. But a lot of people think that Stranger Things ripped off the theme from that, when really it's just the same keyboard guy, like this, playing the same 5 notes. Okay, where was I? So creating an oscillator is actually super simple. In this case, we just ask the audio context to give us an oscillator, and we tell it what type we want. We can change that type whenever we want to change it, and we can set a frequency that we want it to play. So in this case, it's going to be a higher A, and it's going to be a triangle sound. And to demo that, I'm just going to jump right into, how am I doing on time? 5 minutes? I'll just jump straight into here. So I'm doing the same math to get all the notes for the MIDI notes. There's my piano keys, and I'm just doing on piano key down for each item. Where are we here? So in this case, because it's an arpeggiator, I need to make sure that I'm called continuously. So I'm going to request animation frame in here on this redraw method. So this redraw method is going to continuously be called. And when I deem it's appropriate to actually do it, then I will call out to play note. So I will play the note here. The synth setup, where'd we go here? Sorry if I'm moving too fast. So an important thing to get accurate time here is the audio context gives us the current time. And this is like extremely accurate in seconds. So this is an actual hardware time, and it's much more accurate than setting a timeout or doing date.now. So I'll just show you this hopefully awesome sounding thing. So right now it's running and it's looping. It's just not playing anything because there's no keys down. For me to make this work and not actually being able to touch multiple places, I just made it so each key, okay, I don't hear anything. I might need to refresh it. Okay, so, sorry. Yeah, one thing that you do have to be aware of when programming synthesizer stuff is just the fact that you can push your speakers far beyond what they're normally accustomed to dealing with. So both changing from really loud to really quiet very quickly, and also frequencies that they don't normally deal with. So in this case, I'm using a single I think it's a triangle oscillator. Does anyone recognize it? Okay, so sine wave is the top one, and I put a checkbox so I can turn this one on and off. So we have a sine wave on the top and potentially a square on the bottom. And the square on the bottom, I'm actually playing transposed 2 octaves below. So if we switch back here and we play. And we can change our tempo too. And let's throw in that bottom. Is that Stranger Things, or is that Only God Forgives? Unfortunately, I don't have it clear, so I got to go and do this. But that's using oscillators. So there is literally a ton of things that you can do with this, and we've only really just scratched the surface. But I found a really awesome site just in my studies for this, and it's the Web Audio Playground app spot. So here we can add a buffer source. Or actually, we don't want a buffer source. What do we want? We want an oscillator. We can pick what kind of oscillator we want. So we want a sawtooth, and we want a particular frequency. We can route to our output. We can make sure we're quiet enough, and we can run it. And we can change that frequency to what we want. And then we can add another module. Say we want a delay node, and we can route this to here and then this to here, and I don't know how to get rid of this one. Keep it. So there's lots of stuff that you can do. Analyzer is pretty cool. If I do this. So you can see that it's not modifying the data at all, it's just analyzing it. And if I change, it's actually in real time analyzing that data. It's doing fast Fourier transforms on it and outputting the data. And that's what I have for you. So, thank you.
That was sweet.
I got a bunch of links here in the presentation, and if anyone has questions.
All right, yeah, we can take questions. Any questions for Jesse? Oh, we got one over there.
Is it also possible to play long audio files together with short audio files?
Yep.
I have a problem with playing like a metronome on an MP3.
It is possible. You will always have sync issues, though, unless you have some way of, if you analyze the media and find a steady beat within it, then you can sync to it, but you're still going to have to do work to make that happen.
Awesome. Any more? Beer time?
Yeah.
Before we head down, I just wanna take a second to thank everybody here for coming. Thank you.